Welcome back to Pandas Power Up, the place where we learn everything about pandas and how to become a data analysis Jedi. In our first video, we learned about Pandas series and how to create them. Today, we are going to cover series aggregation methods and conversion methods. By the end of this video, you will have a deeper understanding of Pandas series and be able to use these methods to supercharge your data analysis. So let's get started. For this video, we'll be using a dataset from the Effective Pandas book. This dataset contains information on efficiency of makes and models of cars sold in the US since 1984. You can explore and analyze this dataset on your own by downloading it from the link provided in the video description. First of all, we import pandas and we grab our URL and read it. One of the nice features of Pandas is that the readCSV function can accept not only URLs but also zip files. Because this zip file contains only a single file, we can use this function. If it was a zip file with multiple files, we would need to decompress the data to pull out the file we're interested in. So, what is TF? readCSV function returns a data frame. Now, you might be wondering what exactly is a data frame. Don't worry, we will dive in deeper into data frames in our upcoming videos. But for now, it's important to understand that a data frame is essentially a collection of series that share the same index. The first column in the dataset we will investigate are City08 and Highway08, which provide information on mile per gallon usage while driving around the city and the highway respectively. But how we can access our desired series from a data frame? One perspective is to treat the data frame like a Python dictionary. This approach allows us to easily access the series we are interested in by using the appropriate column name. For example, our desired series are these. Let's look at the data. Each series contains approximately 40,000 integer integer entries. Since the data type of these series is int64, we can deduce that there are no missing values. If there were any missing values, the data type would need to be float64 or another data type that supports missing values. The Pandas library provides a lot of functionality. There are over 400 attributes on this series. Now we can start exploring some of the useful attributes of Pandas series. One type of attribute is the aggregation method, which allows us to perform operation on the entire series, such as finding the sum, mean, or max value. These can give us a quick overview of the data without having to manually calculate these values for each individual row. So let's dive into the code and see how we can use aggregation method on our series. If we want to calculate the mean value of the series, we can use an aggregation method like this. Or we can use mean or max. There are also a few aggregate properties. These start with is underscore. You do not call them. They will evaluate to true or false. For example, is unique is one of them. Or is monotonic increasing or decreasing. Here is a neat trick in Pandas to calculate aggregates. If you want the count of value that meets some criteria, you can use the sum method. For example, if we want the count and percent of cars with mileage greater than 20, we can use the following code. We have 10,000 entries that are greater than 20. Or %24 of our entries are greater than 20. But how does it work? First, let's explore what the GT method returns. This trick comes from the fact that Python treats true as 1 and false as 0. If you sum up a series of Boolean values, the result is the count of true values. If you take the mean of a series of Boolean values, the result is the fraction of values that are true. You can use this trick with any series of Boolean values. Great. Another thing that I want to mention is the aggregation method. The aggregation method can accept a list of aggregation functions and calculate them all at once. You can pass in the name of aggregation methods, NumPy reduction functions, or native Python aggregations. Here is an example calling all of these type of reductions. First of all, we import NumPy because we want to use a reduction method from NumPy. Mean is an aggregation method in Pandas that we just pass the name of it with a string value. MPVar is a NumPy reduction function, and max is a native Python aggregation function. Here we have only mentioned some of the aggregation methods available in Pandas, but there are many more that you can explore in the official Pandas documentation. Moving on to conversion methods. You might find yourself in a situation where you need to change the data type of your series. This could be due to lack of type information in your data, or it might simply be for a better performance, as changing types can open up more manipulation options or use less memory. So let's dive into some of the ways you can convert your series in Pandas. To specify a type for a series, you can try to use asType method. Our city mileage can be held in a 16-bit integer. However, in 8-bit integer will not work, as the maximum value of that sign type is 127, and we have some cars with a value of 1500. For example, we convert our series to int 16. And we get back a new series that data type is int 16. But what about converting it to 8-bit integer? As you can see, we don't encounter any errors or warnings, which is quite a strange behavior in Pandas. As you can see, if we get max, we will see 127. Obviously, after conversion, our original data is destroyed. However, if we use int 8 with a capital I, we'll receive an error alerting us about the conversion. Cannot safely cast. The primary difference between int 8 and int 8 with a capital I is the latter support missing values. Additionally, when converting to int 8 with capital I, some safety checks are performed, as you can observe. Using the correct data type saves significant amount of memory. The default numeric type is 8 bytes wide or 16 4 bits, for example, int 64 or float 64. If you can use a narrower type, you can cut back on memory usage, giving you memory to process more data. You can use NumPy to inspect limits on integer and float type. For example, you can see int 62 minimum value that can be held and maximum. Or for floating point data type, you can use finfo, and to calculate memory usage of a series, you can use the n-byte property or memory usage method. This series use about 300 kilobytes. If we convert it to int 60, we reduce our memory usage. As you can see, 300 kilobyte reduced to 82 kilobyte. The value of n byte is just the memory that the data is using and not the ancillary part of the series. The memory usage method has two optional arguments, index and deep. The index argument calculates the memory usage of the ancillary parts of the series, while the deep argument includes the contribution from object types. As you can see, memory usage method return same number with n byte. But if you use true, it calculates memory usage of index values. We extract another series that contain objects from our data frame. As you can see, when we call memory usage with deep equal to true, we get memory used by our individual objects in our series. That's huge. It's about 2 megabytes. Let's explore another data type that we haven't discussed yet, the category data type. We can see that we will save a lot of memory for the make series. To convert to a categorical type, you can pass in category as a type. For example, and if you want to get our memory usage for this series, we can use memory usage method. C. Reduce 2 megabytes to 100 kilobytes. A categorical series is useful for string data and can result in large memory saving. This is because Pandas stores Python strings when you have a string data. When you convert it to a categorical data, Pandas no longer use Python strings for each values, but optimize it, so repeating values are not duplicated. You will have all of the functionality found of the str attributes, but it comes with potentially large memory saving and performance boosts, as you do not need to perform as many string operations. Just I want to mention, it comes with memory saving if you have many duplicates value. And that's it for today's video on Pandas Series deep dive. We covered the basic of series, learned about aggregation methods and conversion methods, and explored some of the attributes of series object. Thanks for watching. If you found this video helpful, don't forget to hit the subscribe button so you don't miss out on future tutorials. And if you have any question or suggestion for topics you'd like me to cover, feel free to leave them in the comments below. See you in the next video.